Hello.
Hello.
A second.
Hi.
All right, sorry guys. Sorry I'm late. I just got home. Yeah, this week is super busy. We're doing some customer audits that going all the legacy part that for those F-22, F-35, F-15 that Northrop Grumman gonna use for their Badger or Ada project. But I'll resume recording. Before getting to engine assembly, let me just show something really quick about the assembly drawings. At this level, I'm not really expecting any details about assembly drawings. So just do the call out, do the bill of material, do the notes, title block, and that should do it. Anyway, it's not required by your second project, but is just something that's to have. And also that will give you extra credit. So you have a assembly, and same thing. You just make drawing from the assembly. Open up a new sheet. So the same routine and drag whatever the view that you think you need. Can fully define your assembly from all the angles. So, for example, since this part is symmetric from two other views, so two views are adequate. And from here, you can say, you can search or you can find bill of material, and this will lead to where the bill of material is under the table. Yeah. Bill of material here. So select a drawing view. Any view is fine. And right here, you can say top level only or parts only. Since we're just dealing with simple simple assemblies, we probably only have two levels, which is the top level and parts level. There are not going to be any sub-assembly within it. So just two parts. And once you click OK, and you have a bill of material right here. So it already specified the sequence, and also the part name is whatever the name you name your component. If you don't like it, you can go back to your component and save as a different name or modify the name, or even modify it right here, but it's gonna break the link, which means if you change your component's name again, it's not gonna be automatically updated. So either keep the link, break the link, up to you, because I only expecting to see a drawing. I'm not going to the SolidWorks file to check it. Once you have the bill of material and you have the cutouts, like making balloon, you're gonna make it balloon manually, or you can make an auto balloon. Since those parts already been specified with item number, so it will be automatically applied. At least for this view, and also you need to make sure all the parts are displaying right in your views. So, and you don't have to over define the balloons. Right, so this way it may look nicer. Since this assembly on have 4 components, so this pretty much does the job. And you just need to fill out the description if you have any description for this component, and fill out the title block right here. And for example, this time we have bolts and nuts, right? It do require certain torque. and you might have a table, a nose table to specify torque. Since these 4 bolts and nuts are the same size, you just need to specify one torque value. And for the engine assembly, it doesn't have any fasteners in there, so you don't have to worry about that. But it's just a brief example to show you how to make assembly drawing with all the views and bill of material. Any questions from this? If not, I'm gonna exit and start doing engine, the modeling of the engine assembly. So I assume there's no questions. All right, let me open up this. Okay, so this is engine block. I demonstrated on the first day of the class, and this is potentially can be your second project. So if you want to follow this, then just follow the recording video, make part by part and make them together, and that's the second project. If not, you can be innovative and do your own stuff. So I'm trying to make a cross section, but it won't allow me because it will have invalid bodies. This will happen all the time because it's assembly. So some parts are placed right at the center line because I make this cross section per one of the base plane, the front plane. So pretty much this is right at the center of this engine assembly. Therefore, some parts is right on the edge and they're cutting it and maybe left a little bit material, and the SolidWorks cannot calculate it. That's that simple. So in this case, you can play around a little bit. So for example, you just move this plane a little bit outward. It might still look kind of the same, or I'll say just the same, but it is offset to the front plane. So that's not enough. That's too much. Yep. So you see, you still can see the cross section, but something, because I moved it too much, and some holes are hidden this time. Just play with it and you can adjust it all the time by inputting values right here. Okay. Yeah. Just by a little bit. No. Okay. Well, anyway, you guys get the trick. Just play with it and little by little, and finally you can make the cross section. But anyway, the cross section will be will only be helpful when you making when you're mating the parts, like those internal parts together. So yeah, on a second project, you can do anything as long as it fulfills the project requirements. You don't have to do the movement assembly. So it can be static and you can choose what can be moved or what cannot be moved, So from here, this engine assembly actually divided into one subassembly and wait. Okay. So this one subassembly, two subassemblies, and one part. Yep, and two another parts. So let's start with the body first. Since this is a main component, let's open it up and get the measurement we need so that we can make a new one. All right. Since it's just a part, so making cross section will be no problem at all. So this one body, you can see is built from a rectangular block, have 4 bores drilled into it, and one rectangular slot, and then 6 holes potentially for fasteners, even though we're not including fastener in this project. And also some circular or semicircular feature for the piston movement. All right. Okay. Let's see. Let's get rid of that. Oh. So it's 6 by 12, and the bore is 2 inches. And center distance is 2.25 from the edge and 2 inches apart. So let me just take it down. Oop. So 6 by 8, 2 inches hole, and 2 inches spacing, 2.25 from edge. All right, and after we've done that, we worry about the feature at the bottom. So let's make a new part. So first thing, even though you haven't started yet, always save it with the correct name into a designated folder. I'll just, I don't want to save it here. In Tuesday. So an easy part for you, you can either save it by name, like engine body, or you can just call it part 1, part 2, part 3, as long as you remember which part is which part. Because remember, finally, you're going to turn in a report with all the screenshots of individual components and the whole assembly, right? You can totally make it part 1, but you just need to make a red caption saying part 1 is what. So I'll just call it engine body. Okay, so it's saved. We can start making it. Yeah, excuse me for 1 second. My keyboard, one of the keys popped. All right, so let's go into Sketch, and the goal is to draw a rectangular body. Oh, I forgot to measure how high it is. All right, but anyway. When start making it 6x8. So in this case, this is going to be the top surface. And let's go back to see. 7. So 6x8x7. Right, in your final report, I want at least one screenshot per component. And after punching that, so this is 6x8x7, right? Okay. All right. So let's start making the holes. And we need to draw circles. Again, if you're not familiar with the reference lines, always do the center line so that you can make sure at least this holes are lie on the center. And for this one is 2.25. Wait, it is 2.25, right? Oh, shorter. For some reason, it doesn't look right. 6, oh, 6x12. Okay. Yep, 2.25. That makes sense. So 6x8, 8 is wrong. We need to change it to 12. And get back to the sketching. And this one is 2. Okay, after we have this one, we just pattern it. Wait, 2 inches hole, 2 inches spacing. That's weird. Oh, 2.5 spacing. Okay. It didn't pattern. Okay. Yep. Once we have the holes, we can make them through holes. Since at the bottom we know it's going all through. And perform the extrude cut. And therefore we have four bores that's going all the way through. And while we're on the top surface, we can also edit these features. So 1/2-inch hole, 3/4, another 3/4, and 6 of them around the corner. And 1/2-inch, 3-inch, and through. Okay. So from what you learned from last class, you can make hole wizard or even simple hole. But this time, let's still just do the extrude cut. Okay. And now we can pattern this. So this length is 6. 6 minus 1.5 is 4.5. Wait, where is that preview of this? Oh, all right. So I need to. Oh, right here. Flip direction. This will have 3. And the spacing will be 12 minus 1.5 is 10.5, 5.25. So it's 12 minus 1.5 divided by 2. And this should do it. All right, so we have 6 holes, but we don't know how deep they are. So is 2.02. Oh, no. To measure this. So from 2 concentric circle is 2 inches depth. So this one, I'm gonna cut it blind to 2 inches. All right, 6 holes being made and the rectangular slot. So this time, use corner rectangle. Actually, I need to use the center rectangle. So this is the center line. .5. That one should be 3. And I didn't measure how far from the edge. quarter. Wait, how come this is still blue? Huh. Okay, for some reason, the center point, okay, the center point didn't lie on the center line. Anyway, let's do it by the hard way, 1.5. Okay. Hey. Okay, there we have it. Okay, let's make it through all. And now we have the exactly same top surface as what we are trying to make. Right? What do I use to measure the cylinders? I use the measuring tool. So I already set up how to I already set up a hotkey and showed it in the class. And this is how I measured it. It's 2 inches in diameter and apparently it's through. So I made the cylinder first. And now I need to start making the bottom features. So before getting to that, let's see what kind of feature is that. All right, so we made a cross section to see exactly what's going on internally. And it looked like a half moon or semicircle shape. And let's verify. And yes, the radius is 2.5. So that means diameter is 5, which is a extrusion cut, but just within the engine block. So the thickness of this extrude cut would be 2 inches. And with no surprise, this would be the diameter, which is 5. Yep. So well, if you're gonna ask a question, please just ask in public. Like if you send direct message to me, like nobody else can see, I have to repeat your question. So it is a screenshot of one component. If you complete, yes. If you complete it, then that's one screenshot of component. But for example, like without this cross-sectional, we hardly can tell there is any internal feature, right? But if you do have internal features, you need to flip it and make another screenshot. Otherwise, I can't tell if you complete this unit or not. All right. So distance.
So, sorry, for this particular case, it'd be a screenshot of both the top and bottom.
Yeah, that's right. Or you can cross section it. Not this way. This way. Yeah, you can show me like this. If you're doing engine assembly, you totally can show me like this because I viewed this thing like 1,000 times already. I know what you're making. But if you're making your own part, like for example, you're making a train, and then like one of the part of the train has internal features, you have to screenshot it twice. Does it make sense?
So the view right now that you just did, this would be one screenshot for the first component, right? One screenshot.
Right.
And what did you click again to be able to get that point of view?
Cross section.
And how do we make it for that specific section, or do we like click like a site?
Once you have the component ready, just click that, and then it will tell you which plane you're selecting as a reference plane to cut it through, and you can set up whatever you want. Well, I'm not very sure why you guys are interested in how to turn in the project first without knowing how to make it in the first place. I mean, if I tell you, okay, screenshot like this, screenshot like that, without knowing how to make this, are you guys able to turn it in? I'm a little bit confused too. And is a group project? Yes, but you can form a group to do the project all together. But turning the same view, that's not acceptable. Okay, you have to have your own assembly. You know what I'm saying?
Wait, so basically what you're saying, if you were to do a group, it's just so you guys can like work together, but you have to have your own thing, right?
I mean, if you
Yeah, okay.
for example, if all 5 people making this engine block, you're totally okay to form it all together and turning the same engine block. And for example, the engine block, this one is 6 by 12 by 7, right? And you don't have to make 6 by 12 by 7. You can make like 8 by 20 by 17, something like that, different dimensionally. And once you've done that, everybody should have at least that 5 people can have the same assembly, but you need to make your own report, right?
Yeah, that makes sense.
Yeah. So no matter what kind of group project you have done, you need to make your own report. You cannot just take other people's screenshot and make your report. That's cheating. You will be reported. That's why I ask you about the group member's name, right? If somebody is nice enough to make this engine assembly and complete his or her report first and post it up on Discord or something, can you guys just change the name and turn it in saying, oh, we're in the same group and this is my project? No. Not even high school allowed that, all right? Okay, let's get back to this. So this semicircle extrude cut feature, let's get some measurement. We already know the 5-inch in diameter, and from this side to edge is 1.25, and same thing from there. And the thickness is 2 inches. Okay. Inches, 1.25 from edge. 5-inch diameter. All right. So at this bottom, we have nothing. And in order to start with that extrude cut, we cannot start from any visible surface from what we see. Otherwise, it will start cutting from here, right? But no, we want the surrounding wall to be intact. and the feature only take place internally, right? So that means we have to make a plane. You can search plane right there, or I have right here. We have to make our own plane to start with the sketch. So instead of making plane, we can make plane from here and just offset it. Very simple. To be 1.25. Reverse the direction. All right. Okay. We can make a plane like this and start sketching on this plane. Yeah, because the edge of the circle is right on this plane. I cannot make a cross section. But the another way we can also do is, let's make an axis first. Make another plane that going through this axis. And start sketching on this plane. And when we do the extrude cut, we extrude cut from both ways. So this way is a little bit complicated, but is, in my opinion, it will be better practice because it's making more sense, right? So let's do both ways so that I can just show you guys. So once we select that plane and remember which side is down, which side is up, and let's start draw some circles. So the circle must start from the edge because we know it's a perfect semicircle. All right, so now you can see the profile of this circle is laid on the first plane we set up right on the edge of the bore. And we can extrude cut it by another 2 inches. Oh, this is already 2. Okay, so one of the feature has done. We can pattern this circle along this direction, and we need 4. And by how much spacing? I'm assuming it's 2.5 because they're gonna land exactly on the bore. All right, so this is one way to make this feature. And the another way is from the here, pretty much you do the same thing, but this time it can be a little bit easier because you can work off your cross-sectional. It can cut with no problem, like perfect center cut, and start sketching. Same thing with the circle. All right, once you have the circle, wait, oh my God. Give me 1 second. All right, this way I won't misclick. Still from the edge and draw a circle with diameter of 5. And here you can see the circle is right on this plane and also right at the center plane of the bore. And now we can perform the extrude cut. But this time is going to be meet plane. And we still want 2 inches because that's the overall thickness. And boom, we have the feature. Same thing, pattern it along this axis, reverse direction, and is nice enough to memorize what I did before. 2.5 spacing, a total of 4 cuts. And here we go. Therefore, we have the bottom feature, and we just need to add more feature to complete this part. Any question from this step?
So if we do the like the second way you showed us how to do it, we don't need to make a front plane, or we still need to make the front plane.
A front plane?
Well, not a front plane, but you know how you made your own planes. You made
Yeah,
two different,
which plane are you talking about? They do have his name.
plane. Ooh, I think it was, yeah, plane 2. Will we still need to make that plane if we do it the second way that you showed us how to do it?
Yeah, so the second way, everything is based on plane 2. And the
Oh.
first way, everything is based on plane 1. I
Okay.
made the 2 plane just to show you guys 2 different methods.
Okay, so plane 1 is for first method, plane 2 is for the second method.
Yes.
Okay.
And insert axis, either here or search axis. And once you click it, for circular feature, you just need to click anywhere of the diameter. It's gonna automatically generate one for you. And for other like random spot, if you click something, it's gonna generate at the intersection. Okay. Any more questions before I proceed? All right, let's get some more measurements. Then we can complete this part. So at the bottom, there is excuse me. Can you mute, please? Okay, I just mute all because I think somebody forgot to turn off his microphone. Anyway, so at the bottom, we can see there is a uniformed circular cut just for shaft. And we take, it's kind of the same thing for those semicircle shape cuts, but this one going all the way through. So we don't need to do something to create a plane like that. We can just work off this surface. So the diameter is 1 because radius is half. So diameter is 1 and it's going all the way through and at the center. And what are these holes? It's 1/4 inch hole. And a 1/4 inch distance. Okay, and we have this another semicircle one, and same thing. We can work off this surface right here, so we don't have to generate plane for that. and diameter is 3, since radius is 1.5. And thick is 3/4. Okay. So let's start from this side, because either side is fine. And start drawing circles. And right here, we need to make the circle with 1 inch diameter going all the way through. And extrude cut it. So you can go through all, you can go up to surface, pretty up to you. I'm trying to show you guys more options you guys have, so you don't have to stuck with one option, right? So just the small holes and this one. All right, and we can start from this surface to make that little hole. And again, along the center line, but actually I don't want to start here. If I start here, I have to go both ways to make my pattern. So I rather start from like beginning or from the end, you know? But now I don't have any reference because the center line only go with the coordinates, right? So if I go right here, I can have a center line. If I go right here, then I don't have a center line. So I need to make a center line. Since center lines are construction lines, you can make whatever or how many you like. It won't affect your geometry. And one thing to be noticed, right here, this 0.25, I'm just being lazy, okay? I measured it from here to here, it's 0.25. That's why I make my model like this. However, in reality, for whole position, you need to remember, we just talked about true position last week, right? For whole position, you cannot reference to some edge that's not a straight edge. This is part of a circle. So the machinist who trying to locate this hole will be having a very hard time to define what's the 0.25 from this edge. So just keep in mind, in the real world, you need to have the dimension labeled from this edge or that edge, or, you know. I'm just saying, but this case, we just do like this. And we pattern this. How many holes we have? Oh, we have 10 holes. Okay, goes all the way there. All right, I made a bad starting point, but anyway. Oh no, I have to start over. I don't want to make 2 sets of patterns. You can keep it there. You can delete it, doesn't matter. Okay, let's make patterns. So this is 2 inches plus 0.5, 2.5. Oh, I entered the wrong thing. Okay, and second direction. Yeah, see, because we have 2 lines of holes, so I do need to use direction 2. So in that case, I cannot start anything from middle. Otherwise, I have to make 2 sets of patterns. This radius of that is what? 1 inch. 1 inch plus 0.5, 1.5. And flip direction. All right, so we have all the holes. We just need to know how deep it is. Oh. So nominal distance is 1 inch. Okay, so we have 10 holes and we start from here, make the final cut. So you can draw a circle from here, or you can also use convert entity. Have this. Wait. This. Okay, never mind. I thought there after I click convert entity, there was a there gonna be an offset. Yeah, if I do this, hey. Okay, never mind. It's I don't know what's going on, but with the circle made on this surface, we cut it to 3/4. Okay. So all we left from this body from completion is those mounting holes. I'm not sure. I'm not exactly sure what these holes does, but since it has it, just let's make it. So 1/8 in diameter, ½ inch deep, and 1, 2, 3, 4, 5. We have 5 holes from here. It's a little bit hard to tell if they are meant to be have 10 symmetrically, but from this distance, it doesn't really look like. So we have to set up a hole right here and then do circular pattern so it can have 5. So 1 and 1/8 from bottom, 1.05 from side, or let's see, we can, well, another way is we can calculate the angle. So have a cross-sectional line made right here. No, not centered line. have a regular line or construction line made from the center to here. And let's make them construction first, so it doesn't mess up our model. That way we can measure the angle. Oh, come on. Okay. So weird. Hey. Or this. Oh, okay. I see what's going on. Come on. .30-degree angle. Okay. Wow, finally. So start from the center. .25 and 30 degrees from the bottom, and we pattern 5 with also 30 degrees. How much was that? Okay, 2.25, 30 degrees. And what is 1/8 hole? Half inch. Okay. All right, like let's make this plane and start sketching. It's pretty much we just need an object line and we can start regulate this to be 30 degrees. Going to be a construction line. Now let's set up this hole right on this line for 1/8. And with that being set up, yay. I need to make the circular pattern. Since we already made one axis, oh no, the axis is that. Okay, we don't have a revolving axis. We need to make one. So this is where we reference as the origin, right? And we need to make an axis go through this direction so that these holes can reference the axis and be patterned radially, right? Yeah, radially. So once you click the axis, any circular surface that with the same center axis can be used to create this. So I can use this, I can use that, or I can use this. All right. So I'm gonna give you the same thing. And now let's jump back into that sketch and make a pattern. Okay. What kind of problem do you guys see here? Can I make the pattern? Come on, guys. Yes or no?
No,
Why is that?
I don't know.
Anybody knows? So can I start making the circular pattern for the hole that we're trying to make right now? Yes or no? And if you say no, why we cannot make it? The arrows? All right, we cannot make it because the axis we just made is not displaying or is not showing. Why is that? So the axis we made, it is right here. So it do exist. But once we go into the sketch and trying to make a circular pattern with respect to this axis, it is not showing up. The answer is because this arrow in this feature tree is beneath this sketch. So that means if you do any operation in this sketch, you can only see the features that above it. In that case, we need to move the sketch down or make the axis up. As long as your axis is not referencing any, as long as your axis is not referencing anything that it's going to get on top with, then you're fine. If your axis is referencing anything from the sketch, then it cannot be moved on top because you'll lose your reference. Therefore, the axis won't be exist. But in this case, the axis is referencing this feature, and this feature is all the way right here. So if we try to move this axis, go all the way above, you see the little enter sign became a invalid sign. So this is how far this axis can go. That's it. It cannot go above. All right, this is kind of important. So I hope you guys stay awake and can memorize this. All right, let's proceed with this sketch. So now if I go circular pattern, the axis is there for us.
Professor, I don't think we're able to see anything. It's just showing the
It froze again.
yeah.
Can you guys hear me now?
Yeah, we can hear you.
Okay. Where did I lost you guys?
I think it was the placement of the axis.
So did you guys hear what I explained the position of the axis and the sketch?
Yeah, we heard that. It was like right before you moved it, it froze.
Okay, so pretty much like it was. Okay, so it was like this before, right? Because I created the axis after I created this sketch of the hole. And if I go into circular pattern of this hole, I'm not able to see this axis because it's created afterwards. However, we can change that just by simply just by dragging this up. So that once the axis feature is above the sketch, then during the circular pattern, you're able to see it. However, there's a limit because the axis is made by this feature, right? We use this feature as a reference to make this axis, which is right here. This axis can no longer cannot be moved on top of its own reference feature. So right here, you can see like my cursor became invalid, right? But anything after that, I can move it anywhere I want. So that's the only restriction. And moving features is quite important. You're going to use it all the time. Therefore, I want you guys to memorize this. And let's go with the circular feature on this little hole right here. Now we can see the axis going through the entire bottom, and we can select it. We can select it as reference. And here we do, since it's automatically 360 degrees, we don't need that. We don't even need total of 5 holes, right? And 5 holes with 30 degrees, that's 150 degree. Wait, total 5 holes or 4 holes? 1, 2, 3, 4, 5. Total 5 holes and a 30 degree, 30 degree, 30 degree. Okay. I mean 120. Oh yeah, it's 120 because it's whatever in between. We only have 4 spacing distance. All right. So after we made okay, so after we made these 5 holes with circular pattern, we can cut it. By 1/2 inches. All right, so this completes the engine body, and first thing ever, once you think you're done, first thing ever, just save it. So Control S, you save it. Therefore, you don't lose any essential work. And there we have it. This is the original one. You can tell it's called cylinder body, and this is what we just made, the engine body. Okay, any questions? I extrude for the circular pattern holes, I extrude cut them 1/2 inch deep. Yep. Really? No questions? So today, this is all I want to cover. I'll upload the recording. And also I want you guys to start practicing this engine block body as soon as possible. These are all the necessary measurement. You guys can just take a note right now and try to make this without the recording video. And yeah, it will be after Thursday night. I figured if I post it before Thursday's night, like Thursday nobody gonna show up. So practice this because it's quite important. And starting next week, I will speed up for the rest of the engine assembly. I won't be going over too many different options unless I feel is necessary. So treat these because they're gonna use, I'll say like 95% of the same feature. Extrude cut, pattern, circular pattern, make a plane, make an axis, you know, stuff like that. So I did a special for you guys. I slowed down in this engine body and try to explain the logic and go with different options so that you will have a better understanding of how to making simple features. But from next week, I will be speeding up a little bit or a lot and make the rest of the component. It's not going to be one component per class. All right. So I want you guys to practice as soon as possible. And next week, I will leave about like 30 minutes to answer questions. If you have any modeling questions and all that about this engine body, that would be a perfect time to ask because everybody's there. I just need to answer the question or do demonstration once, right? If you don't practice until like the last week and tell me how can I do this, it'll be too late, to be honest. All right, this entire engine block assembly even took me about like 2-3 hours. It will take you about maybe 20-30 hours, to be honest. So start as soon as possible and gather questions. I come to class, and after I cover the material, we're gonna answer the questions, do demonstrations, stuff like that. All right. If you have no more questions, you're definitely free to leave. And if you have any questions, now is a good time to ask.
Thank you, Professor. Have a good one.
Thank you, you too. Have a good week. And don't forget to practice.
Thank you, Professor. Have a nice day.
You too. Have a good night.
Thank you, Professor. Have a nice weekend.
Thank you. I'm a little
Have a
bit
good
far
one,
from
Professor.
weekend. Thank you. Any questions from you guys? Okay, if you have no more questions, I'm gonna drop. All right, see you guys.